And hello. Today we'll be looking at the probability of events, or as you might have learned in primary school, the chance of events. So this is your introduction into probability or chance. And what I want to do is I want to look at kind of an example that involves just intuition more than maths, just intuition, thinking about it. I'm going to look at a game. So we all play board games and dice games and card games at home. So this might be a little bit familiar to you, and there's a little bit of a strange thing going on, but I'll talk about it. So here's the thing: Mick and Mary are playing a game. They roll a 13-sided die. Now, 13-sided die. Now that might be a bit confusing, but it looks like this. It's just your, like, let's say your normal cube die would have 6 sides, 6 faces. So that would be your 1, 2, 3, 4, 5, 6. This shape has 13 faces, so it would be a 13-sided die. So you can see there's 2, 13, 6 or 9, 7 and 1. So all the numbers from 1 to 13 are on this die. So here's the game. Mick and Mary, they're rolling the die. If the number is even, Mick wins. If the number is odd, Mary wins. So the question is this a fair game? And then obviously, is there a better option if it's not fair? And what do I mean by fair? So fair means that they have an equal probability of winning. Or another way of thinking about it is, if they played the game over and over and over again, they should both win roughly the same amount of times. So let's say Mick and Mary played the game and 100 times, and Mick won 48 times and Mary won 52 times. Now, yes, Mary won a little bit more, but they're both roughly the same. They're both roughly around 50, so it would be pretty fair. But let's say Mick won 90 times and Mary only won 10 times. Now, that doesn't seem fair, because there must be something going wrong there, because they should be closer to half and half. While, obviously, if Mick is winning 90 times, something's wrong. It's not a fair game. So again, fair just means there's an equal probability of winning for both players. So let's look at this in a little bit more depth. So I have here all the possible numbers rolled. So you could roll a 1, you could roll a 2, 3, 4, 5, 6, all the way up to 13. And remember, the rule is, if the number is even, Mick wins. So that means if it's 2, 4, 6, 8, 10, 12, yeah, all divisible by 2. If it's odd, Mary wins. So that's 1, 3, 5, 7, 9, 11, 13. So the question is, let's look at the odd. How many odd numbers are there here? Well, there's 7. I just counted them out. There's 7 odd numbers. So Mary wins. Out of the whole die, there's 30 numbers. 7 of them are odd. Then the even numbers, that's the ones that Mick wins. Well, there's only actually 6 even numbers. So just using your intuition, is this a fair game? Forget the maths for a second. There's more odd numbers than there are even numbers on this die, so they're rolling and rolling it. Do you think it's a fair game? Well, no, it's not fair, because there are more odd numbers than even numbers. So the odd is more likely to come up, because there's more of them than there is even. So we say you are more likely to win with odd. So the question is it a fair game? No, it's not fair. So that was just more of an intuition thing. But what if we wanted to look at the maths behind it? What about the probability? So when we say probability, we're looking for an actual number. So as I said, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 13. There's 7 odd numbers and 6 even numbers. So if we ask the question, what is the probability of odd? I would say 7 out of 13, and we write it as 7 over 13, or 7/13. Now, how did I get this? Well, how many numbers are there all together? What's the total amount of numbers? There's 13. And how many of them are actually odd? Well, there's 7. So it's 7 out of the whole 13 are odd. So the 7/13. That's the probability of an odd number being rolled. What about an even number? Or sorry, well, I didn't actually describe. This is 7 represents what we call the desired event. So in this case, the odd numbers, the ones we want are odd numbers. And then the total number of events, so that's all the numbers, well, there's 13 of them. So then the probability of an even number, well, there's 6 even numbers. How many numbers are there all together? There's 13. So the probability of even is 6 over 13. Now, what does this number actually represent? So 7 over 13 is just a number. It's just a number. It's I don't know what it is. I'll pull out the calculator now, actually. Why not? I should have probably done this before, but we'll look at it now. It's 0.538 blah blah blah. So what does 0.538 actually mean? That means if I rolled this die 100 times, the probability of me getting an odd, or the expected amount of odd numbers I would get, is 100 multiplied by 7 over 13. So if I rolled the die 1,000 times and I wanted to find, well, roughly how many odd numbers would I expect to get, well, I'd multiply 1,000 by 7 over 13. And just like that, if I wanted for even numbers, I would multiply it by 6 over 13. So probability, this number, gives me kind of a way of determining how many times this event would actually happen. If I roll the die 1,000 times or 50 times or 70 times, this tells me if I just multiply it by this, I can kind of guess how many times roughly it would be. So this is the main thing. A probability of an event occurring, so this is like the die roll, an odd number rolling or an even number, is the number of favorable outcomes divided by the number of possible outcomes. So in this case back here, there was 13 numbers altogether, and 6 of them were even. So we're looking at even. So there was the desired outcome was even. So there's only 6 even numbers. And the total possible outcomes, the total amount of numbers, was 13. So that's what I mean by possible outcomes, just all the outcomes. And the ones we're particularly looking at, those are the favorable outcomes. So yeah, super important that you remember this. This comes up all the time, and it's based. All the probability is based around this kind of idea. So definitely remember it. Okay, so as I always do, I'll give you some time to do the recap questions, and then I'll go through them. So the first one, the probability of it raining is 4 over 14. How many days would you expect it to rain in a week? So, how would I do that? Remember, I told you this number, the reason it's important is we can just multiply it by whatever, how many trials we're doing this, and we could figure out the expected number. So in this case, we're saying how many days would you expect it to rain in a week? So there's 7 days in a week. So if I pick any day, the probability of it raining is this, 4 over 14. So 7 days, well, I'd have to multiply it by 7. So 4 over 14 times 7, that's 28 over 14, or 2. So out of a week, we'd expect 2 days to rain. So again, I'll say that again. This represents the probability for 1 day. So if I pick any day, I'm expecting this number, 4 over 14. That's the chance of it, or the probability of it actually raining. If I wanted to see 7 days, well, I have to multiply it by 7. And then I found it was 2. So out of the 7 days, I expect 2 of those days to rain. Okay, what is the probability of it being the weekend? So what's that mean? Well, let's say today. Today is Tuesday, as I'm recording this, but if you pick any day randomly, what's the probability of it being the weekend? Well, think about it. There are 7 days in a week. How many of them are the weekend? 2 of them are the weekend. So the probability is 2 over 7. Now, how did I get 2 over 7? Well, I'm looking at 2 of the days out of 7 of the whole day. Like the whole week is 7. While 2 of them are the weekend. So what's the probability of it actually being the weekend? Well, it's my favourable outcomes, or the 2, the one I'm actually looking at, the weekend, out of the total number of outcomes, which is 7.